Thank you, everyone. My name is Mr. Ben Pudiane. I am back with you today. This is our interesting lessons during this lockdown. And then this week is one of the hectic weeks where we are only going to have 3 lessons. Last week when we were together, we talked about strengthening the materials. So we learned about ways in which materials can be strengthened so that they are rich and they can carry load. So today, we are also continuing with other experiments. And then furthermore, this is the lesson that is going forward from the last lesson that we have been doing. So it is a continuation. If you are not there last week, please note that we learned about strengthening materials so that they can support the load. So to start with, on this lesson, we've got simple objectives, the objectives which we must meet at the end of this lesson. The objectives of today are as follows. On the objectives part, you must be able to explain how to make circular, triangular, and square paper tubes. You must be able to explain how to make circular, triangular, and square paper tubes. Number 2, you must be able to explain which of the shaped tubes is the strongest. So it's very important. It's very important that you are able to test and see which one is the strongest among the 3 types of shapes that we are going to make. Now let's start with our lesson. Let's start with our lesson. We can move to the next slide. We can move to the next slide. Yes, I'll ask Mr. Kalis to move to the next slide. Yes, those are our objectives that I've just told you, that you must be able to make circular, triangular, and square paper tubes. And number 2, you must be able to explain which of the shaped tubes is the strongest through testing. You are going to test, and at the end, you will see which one is the strongest. We can move to the next part. Yes, now, paper pillar. A hollow paper pillars. We need to find out which of the paper pillar is the strongest. Why? We need what? We need an A4 paper, a tape or a sticky glue. But with me, I have got old papers, used papers. Here are they. All these papers, yes. Now I also have a tape with me. And then I'm going to use this tape and the old papers to make the shaped tubes. Yes, so and test which one is the strongest among the 3 shaped tubes. Now we can move to the next part. We can move to the next part. Yes, I said we need those things. Do you see that paper? We need 3 of them. We need a glue. If you don't have a glue, you can use a tape. This is the lesson for today. It's very, very important, more especially if you want to pass your exam and practical task for grade 4. It's very important. The process is as follows. The method, the next slide. On the next slide, we have the methods. Yes, you must roll 1 sheet of paper into a circular tube. I must roll this paper into a circular tube. I just roll it like this. Roll it to make a circular tube. I roll it to make a circular tube. When I have rolled it like this, then I am going to use, do you see it's a tube? Yes, you can see inside, is through it to show that it is a tube. Then you use a tape. I use a tape to tape it here so that it can stick. And it will look like the shape you see on the right. This shape will look like this. If you finish it, it will look like this. It will look like this. This one I've already made so that I can save your time and not bother you. This one I've already made. Yes, it is like this. It can stand like that. Now, number 2, you must fold one sheet into 5 equal sections. This is the second one. You fold one sheet of paper into 5 equal sections. Now I'm going to fold this one into 5 equal sections. Now I'm going to try to fold it. 1, 2, 3, then number 5. Now I did fold this one into 5 sections. Do you see? Yes. 1, 2, 3, 4, 5. These are 5 sections on this paper. Now, after having folded it into 5 sections, then I am going to stick it so that it makes a square. Look, it will be like this. After you shaping it into 5, because these 2 ones, they join here. That's why you make 5. But when you fold it, it is going to make 4 corners. This is a square tube. Then I use the tape here and join it together. I'm going to use a tape to join it. Then when I join it, it will look like this one. This I have joined it. I join it, then it looks like a square tube. Then I put it aside. I put it aside. Then I continue. The next one, I fold one sheet of paper into 4 equal parts. This one I fold into 4 parts, not 5. I'll fold this one into 4 parts. This one will be 4 parts. With the old paper, then I try to fold it quickly into only 4 parts on this one. We need only 4 parts. Then I quickly fold it so that it gives me 4 parts. Yes, there is my 4 parts. Here is my 4 parts. Here is it. 4 parts. 1, 2, 3, 4. 4 parts. But when you join these 4 parts, they make a triangle. I join them together like this. Then it makes what we call a triangle. Now it's 4 parts. You see, when I join it, it does not make 4 parts. It makes a triangle because the 2 sides must be connected. You must be able to put the tape or the glue to connect the last 2. So now, after having connected, then my shape looks like this one. After I've just connected it, it looks like this one. Now, I'll be having about 3 shapes. The first one is the circular shape. Here is it. The second one is the rectangular tube, and the fourth one, the third one is the triangular tube. At the end, you have these 3 shapes. Now, let's continue. Let's go to the next slide and see what is it that we must do now. Now we have these 3 shapes. There's something that we must do. Yes, we need to stick the edges of paper together. I did so. I did stick them together. Yes. Now you also need to fold it. Now I'm asking a question. Why do you need to stick the edges of paper together? What do you need to stick the edges together? What is it that you need to stick the edges together? Anybody can give me the answer for that? You know, I told you at the beginning that for the shoe to be connected, something must be used to stick so that it does not fall apart. Kamogelo, do you have the answer for that? Kamogelo. Yes, Kamogelo did raise the hand. Yes, what do you say, Kamogelo? Okay, no problem, never mind. Yes, it's very important to stick it so that you hold it in place. You keep the shape the way it is. That is why you have to stick it with the tape or the glue. Those are the two things you can use as grade 4 learners. Thank you to everyone. It seems everybody knows. I'm very happy that you know the answer. Number 2, what tube shape will you make if you fold your sheet of paper into 5 equal sections and stick the last 2 together? Yes, which shape are you going to make if you fold your sheet of paper into 5 equal sections and stick the last 2 together? Somebody have got the answer here? Yes, somebody got the answer here. Kamohelo, what do you say? Naledi? Naledi? Okay. No, it's seemingly, yes, you know the answers. You know the answers, I know. Okay, yes. When you fold 5 sections, you will end up having 4 corners. The shape that you'll have is going to be called a square tube. Yes, you'll have a shape like this one because number 1, 2, 3, 4, and the one is folded. Thank you very much. Thank you, Kamuhelo, and everyone for giving me the correct answer. You are very, very clever people. Now, the last one. What is the name of a tube shape? Yes, what do you call this tube shape? This one. You can ask your parents this one, a tube shape. Yes, do you see? It's a tube shape, this one. What do we call it? What do we call it? What do we call it? Yes. Okay, no, you know the answer. Thank you for that. Let me see. Let me see someone will answer. Yes. Laurentia. Laurentia? John Paul?
Yes, sir.
Yes, he say, okay, circular tube. Thank you very much. You know the answer. It's a bit rainy where I am. That is why I can't hear you very clearly, but the rain is very hard. It's raining very hard here. So thank you for the answer. Then the other name, which is very important, you must know, it is called a cylinder. It is called a cylinder. This is a scientific name for this one. It's a cylinder. It's called a cylinder. Yes, we called it when these people using the metals, connecting the metals, they call it the round tube. Yes, the round tube. But now we call it a cylinder technically. So now let's move forward. Let's move to the next part and see what it holds us for us. On the next slide. The next slide talks about the force acting on the object. Yes, the force acting on the object. You know, people, when you throw things up there, they fall downwards. You try to put things up. You throw it upwards. then it comes down on its own. It just goes down. There must be something that makes it to go down. Yes. Now, objects, yes, acting on force acting on objects. All objects on earth fall down the earth when they are released. Leaves, fruits, balls, they fall downwards. Everything falls downwards. And there is something that makes it fall down. We call it force of gravity. Force of gravity. This force wants things to fall down. When you take something upwards, then it goes down because of this. Now, it is important for you to know that objects keep on standing, but there's something that want to make these things go down. It's the force of gravity. It wants to take them down. The houses you live in, the force of gravity is busy pushing them down. Yes, even when you are standing, it is pushing you downwards so that you can stand. Yes, when you want to jump upwards, it takes you down. It's the force of gravity. It pushes everything downwards. Yes, it makes the things to go down. Now, the buildings must be strong so that they don't fall. All buildings, your house must be strong. It must be very strong. If it's not strong enough, it will fall down, but nobody will take it down. The force of gravity will make it to fall down. So now we must find out the shape that has more strength to hold more weight in this investigation. We must find out which one among the forces that I'm just going to, among the shapes that we have made. I'm sure you made your own shape. I'm sure you made, if you did not make your shape, just look at my shapes that I made here. Now, I believe you understand this part, that nobody pushes things down, but only the force of gravity is natural. It just makes things to go down. When you put something up, it goes down. Now we must try to find out, if you are an engineer, you have these three shapes. Which one is going to find it to be the strongest shape? That is what we are investigating today. Yes, that is what we are investigating today. It's very important. Now, we can measure the strength now. On the next slide, we can measure the strength. We can measure the strength. Yes, I'm going to start with the rectangular tube. I'm going to start with the rectangular tube, this one. I put it here. I want you to see me. Let me put it right. Yes, so that you see it correctly. Here is the rectangular tube. What I need to do, I need to put the books on top of this shape. I need to put the books on top of this shape to see how many books will stand. Yes. But first, I must put something to see if it is straight. I put a pencil here to see if it is straight. Then thereafter, I put books on top. I try to pile books on top of this shape. Now here are my reading books. Here are my reading books. I'm going to put them on top. I'm going to put these books on top, but one by one. I'm going to see how many books will be put here before it falls down. Then I start number one. Here is number one. The first book, the second book, the third book, sorry, the fourth book, number 5, number 6, You see, now that it was able to hold 6 books. This shape was able to hold 6 books. This square tube was able to hold 6 books. You see where it failed? Yes, it failed on its own. It had a bend here on its own, but it was able to carry a number of 4 books. Sorry, 6 books. I'm sorry, 6 books. Now I'm coming to the rectangular tube. I'm coming to the rectangular tube. Yes, here is the rectangular tube. Here is the rectangular tube. Now I must also put the books on top to see how much it can hold. How much it can hold. Let me start with this one. 1, 2, 3, 4, 5, 6. It was able to hold 6 books. Yes, it also fell down. Look where it failed. Yes, the rectangular tube failed here on the spot. It just bent on its own. Yes, that is a failure. It was unable to hold many books. It was able to hold 6 books as well. Now I'm coming to a circular tube. I'm coming to a circular tube. Here is it. This is a circular tube. I put it here the same way. Now I'm going to pile the books on top. 1, 2, 3, 4, 5, 6, 7, 8, 9. I now put the big one. 10, 11, 12. Now I put the tape. 13. It is not falling. Now I don't know what to put else. It was able to put 14 books on top, plus the tape. Very heavy. Now, you see, this one was able to hold lots of books on top. Yes. Now, did you see the rectangular tube was able to hold 6 books? A triangular tube was able to hold 6 books. Now, with the circular tube, it was able to hold 14 books. Now, let's go to the table on the next part. You must be able to fill this table. There is a table that I've given you. The table on the next slide. On the next slide, we have the table. You must record the information here, the shape of the tube, and number of books it can support. You write on the circular, it was 14. The square, we got only 6 books. Triangular, we got 6 books. This is what you must do. Thereafter, we don't end here. This is the data that we have collected on the investigation that we are doing. On the next part, here is the bar graph. And this bar graph, you must be able to draw that how many books did the circular tube manage to carry. You see, the graph is like this. it have got the columns and the rows. Columns are going down. I mean, if you measure up from up downwards, is a column. Then you measure from the left to the right, is a row. Now, the graph have got what you call the left-hand side. On the left-hand side is the y-axis, and then at the bottom, where I wrote type of shape, is the x-axis. All the graphs have got the y and the x. The y and the x. Now, number of books is the y, and number and type of shape is the x. A graph must always have those two things. It must always have the x and the y. And the x is just horizontal, meaning it is downwards, and the y is on the side. Now, you see the zero here? Yes, there's always the zero at the edge. On the corner where the x and the y meet, there is a zero. Now, from 0 to 6, those are the number of books. But for your graph, you can make it longer, more than 6. You can make it to go up to around 20. Yes, even 15 upwards. And then now you got, oh, how many things that you were testing? I was busy with 3 things. That's why I made circular column, rectangular column, and triangular column. Those are the 3 columns that I have. So draw your own graph on the paper, and then you will see which shape have got the tallest bar. Tallest bar. It means you are going to shade. You make the shade for the circular tube. You are going to make up to number 14. I don't have number 14 here. You make up to number 14. For rectangular tube, you make shades up to number 6 because the data that we got is 6 books. And then triangular is up to number 6 because we also had 6 books. Now let's come to the question. Why do you have to place the tube on a flat surface? This is a question I want you to answer. Why do you have to place a tube on a flat surface? This surface was very flat. John Paul. Okay, no, thank you, John Paul. Thank you. The thing is that we want it to be a fair test. We want it to be a fair test. Yes, because if we put it aside, Laurentia, good. If you put it on the side, it will be unfair test. It will be a very much unfair test. It must be on a flat surface, very flat surface, so that it is a fair test. Yeah. Number 2, why did you have to add objects on top of the tubes? Laurentia is always there with us. Yes, I thank you for participation.
To see how many books it can support.
Good, Laurentia. Thank you very much for your answer. I'm very happy because we are very clever again. So yes, you want to know how many books, you want to find out how many books it can support. Now, what do we call the force that make things to fall down? Yes, it's still Laurentia again. What makes the things to fall down? Laurentia.
Gravity.
I'm here. I'm still waiting for the answer.
So it's gravity.
Good, gravity. And this gravity, it makes everything to fall down. Yes, it doesn't spare anything. Whether it's water, whether it's rocks, whether mountains, things must just go down. So now this force makes things to fall. Number 4, Why is it important to investigate the strength of structures? Yes, why is it important? Why do we have to investigate the strength of the structures? Yes, Uze. I don't know whether I'm spelling your name, I'm getting your name correctly. Yes, somebody the answer? Why is it important to investigate the strength? I just need the answer for this question. It is important for, why is it that important? Laurentia again.
To see
Laurentia? Hello?
to see if it's strong or not.
Thank you very much for the answer. Yes, to see if it is strong or not. Because structures are made for the people. They are made for people to live inside them. So it is important so that you know whether the structure you are living in is strong or not. So you cannot risk to put the people inside the building which is not strong. So even the animals must be in strong structures. That is the answer I needed. Thank you very much. And now, to end the lesson of today is that we have learned. I can go back to my objectives to see what is it that we were looking for today. I said, you must be able to explain how to make circular, triangular, and square paper tubes. If you did try to make it, it means you now know how to make it. Then I'll be very happy to see if you can make it. Thank you for that. And then you must be able to explain, number B, which of the shape tube is the strongest through testing. Then we did the test. You see how we did the test, even during your spare time. Try to do that test. Books are different. You can use the books that you write on at the school as the test. Here I was using these smaller books. But you can use different books. It will depend. It will carry different books, but you'll find out that the circular tube is the strongest one. The circular one is the strongest among the three. That is why buildings are made, the pillars, they make them circular. It's very strong. Now, for the helpful links, if you want to know further about this lesson, you can go to YouTube. You see the link that you see above there? Yes, there are 2 videos you can watch. The other one is very short, and the other one is a bit longer, 6 minutes. Then how to do a paper book tower is an experiment. You can investigate further. And thank you today for joining me again. I'm happy to have you back. At least we could communicate today, and I was able to talk to some of you. And then bye to all, and I love you all, and thank you for today. Bye-bye. Love you all, and then see you again tomorrow, where we are going to Isaiah. Okay, somebody want to say something? Okay, maybe they are saying bye-bye. Yes, thank you for this lesson of today, and thank you for Mr. Khalid. Thank you, Laurentia, for your answers. Come back tomorrow. And then, yes, it will be also interesting. So this part helps you to learn about the practical task. Since you know that science, we've got a practical task as a task for term 2. And thereafter, you're going to write a test after having done the practical task. And we got the marks for the practical task. So you must be able to complete your practical task. Yes, Mufunwa, good. Thank you very much for being part of us. Thank you to everyone. Love you all. I enjoyed this lesson. Thank you, Mr. Khalid. Yes, This is the end of our lesson for today. Then thank you very much for participation.